Thank you for the very nice intro, Brent. And as Brent said, we are MachineMetrics, and we're a local startup based in Northampton. We're post-Series A, growing at triple digits every year, so we are in hyper-growth mode, and I'm here to share some of the work that we're doing on the data science side. So what field do we work in? Specifically, we work with machine shops, so manufacturers. A lot of our customers are actually local in the Western Massachusetts area, but essentially the machine shop world is kind of antiquated. It's been stuck in the same patterns for decades now, and it hasn't really embraced advanced analytics or data science like other industries have. What you see here is actually one of our customers before MachineMetrics. They have to basically walk up to each and every single machine to figure out what's going on, and that's a really cumbersome process that can be very labor intensive and also not very efficient on your operations. So what do we do? Our solution is a software and hardware solution where we basically go into the cabinet of the machine tool and we install two simple things, an edge device and an I/O device to track every single signal that comes off of that machine tool. So what does that result in? So these are the two things we install, that's it. And our customers realize a tremendous benefit from this because they can essentially see all of their machines now on one screen and see things like how many parts have been made, utilization, patterns over time, all sorts of things. So this is one of our local customers up in Greenfield, actually VSS, and when they installed MachineMetrics, they found that they were identifying spots in their factories where the machines were just sitting idle for hours and nobody knew about it. So why are we emerging now as opposed to a couple of years ago? Well, we'd like to think of ourselves as the first vertically integrated out-of-the-box platform for manufacturers. Previously, what's happened is large corporations have had to go into machine shops and go through months-long integrations. So these things take 6 to 12 months, they're very labor intensive, and they're basically made unaffordable for a lot of these mom and pop machine shops. And our solution, through the technology that we pioneered, can basically help manufacturers get up and running with dashboards and analytics within the span of a couple days to a couple weeks. So what are some of the signals we get off of machines? We can basically signal and detect anything that's needed to make the machine run. So everything like sensor data from vibration to amperage, all the way down to what the machine is commanded to do in terms of feed rates and load and rotary velocity and things of that sort. So what can we actually do with all this data? It's cool that our customers get all this great information and they can get dashboards, but we've expanded to the point now where we're on thousands of machines and hundreds of different machine shops across the United States. One of the big problems that's actually in industry right now is there's a lot of waste of tools. So when machinists install tools on their machine tools, they often don't know what the true life of them are, so they start retiring them well before they're actually exhausted. And what this results in is not just environmental waste, but also a lot of cost to the factory that doesn't need to be there. So this is how they used to tackle the problem, which is literally with a whiteboard. They used to write how many parts they've made, and once they've gone over a certain threshold, essentially they said, okay, well, we think we need to change the part now. Obviously, this is not a very scientific or rigorous method, so actually people in academia have started researching this topic about, I'd say, 10 to 15 years ago. So toolware prediction is an active area of research right now where people will often take a very complex experimental setup in a laboratory environment, and you'll have microscopes and you'll have sensors. You need to take apart the machine tool and break apart the machining table to install these very expensive sensors that cost tens of thousands of dollars. Most of our customers, they really don't like this. One, because it voids their warranty, but also because it's not really economically feasible for them to have this type of setup. You know, they go like this, and we go like this. So what are we proposing? So in collaboration with an academic partner, we are actually using new methods of transfer learning to try and solve this problem. So just to give you guys a brief overview of transfer learning, it's at a very high level, taking knowledge from one model and extrapolating it to a different domain. So previously in supervised or unsupervised learning, what you have is people only being able to come up with solutions that are interpolating results. So you show a computer millions of images and you show them a new one, and it has to fall within that in order for them to be able to predict what it actually is. So with transfer learning, how it works is it's kind of like with a chef, where if you know how to cook really good Chinese food, you know how to make really good wonton soup, essentially you can take that knowledge and cook a different type of cuisine, like Indian food. You know, you have a better chance of making good Indian food than you know, someone who doesn't know how to cook at all. So what does this look like when applied to machining? So essentially what you have here is, in a laboratory environment, we simulate a bunch of different cuts, so a bunch of different materials and work pieces, and we get the signals from them, and we construct a neural network, most likely a LSTM or RNN model. Essentially what it looks like from that standpoint is, for each and every tool and material combination, you have one specific model. So you have a toolware model for stainless steel and a 331 drill bit. Well, that's not very useful, right? Because you need to repeat that for each and every single combination. And so what do we propose? Well, based off of the data that we've collected over the past couple of years, we have a massive database of tool and material combinations. So in this case, it's a material of Inconel with a 331 drill. And essentially we can consult these standard lookup tables for these materials to, you know, figure out their shear stress or, you know, their thermal conductivity, and basically use a physics-based model to shift the previous models constructed in the laboratory up and down based off of what we see in these lookup tables. So that's where the power of transfer learning really comes in. And we're currently partnering with UCF right now to do this project. And that's just one of the things we're working on. But we are actually looking for a data science intern for the summer, maybe a data scientist, points for all of these things. And it should be noted that we do work with defense contractors, so we do require either citizenship or a permanent residency in order for you to be able to work for us. So this is just a little graphic right here of transfer learning, and you know, you can see with transfer learning you get a higher slope and higher asymptote, and you know, MachineMetrics with you has a higher slope and a higher asymptote. So that's just my little cheesy joke to round out the presentation. Thank you.